and the Indian Society of Non-Destructive Testing, among many others. It's truly a great opportunity for us to hear from a scientist of his stature, whose expertise and contributions have significantly advanced India's space missions and aerospace research. His journey is an inspiration to young minds who aspire to continue and contribute to science and technology just as great visionaries before him has done. So, without further ado, let me extend a warm welcome to Sri Ravi Kumar Verma as he takes the stage to share his insight and expertise with us. Please, sir.
Thank you, Kamakshi. I'm audible?
Yes, sir, you're audible.
Okay, thank you. So first of all, good evening to all NIT Kurukshetra students. And it's a indeed pleasure and honor to be addressing on National Science Day, the 20th February 2025. What is the better day for that? And say as Sonakshi told it, Kamakshi told that we are celebrating this 20th February 2020 to commemorate the Raman effect, or maybe I can say the scattering of light discovered by none other than Dr. C.V. Raman, right? Dr. Chandrasekhar Raman. Everybody aware about that since the discovery has been maybe near about going to complete a 1 century, right? I think 97 years are over. 1928, 28th February 19, 1828, 1928, sorry, 1928, the discovery of this Raman effect or maybe scattering of this light has been by Dr. Raman. And the father of Indian space program, Dr. Vikram Ambalal Sarabhai. He is his PhD scholar. He is actually a student of Dr. C.V. Raman. And after that, Dr. Vikram Ambalal Sarabhai became the father of Indian space program. And it's a truly honor to be addressed to NIT Kurukshetra student on the National Science Day. And I am going to touch upon the Indian launch vehicle technology, means rocket technology. What actually till now we have did and what we are going to do. I hope you people maybe like it. And most of them are belongs to that mechatronics, mechanical. That is actually your domain of expert in which most of the launch vehicle rocketry basically belongs to aerospace, mechanical, mechatronics people. So I'm going to share my slides with you. This slide is visible?
Yes, sir, it's visible.
Okay. Yeah, I'm going to talk on Indian launch vehicle means rocket technology, how we have evaluated. There is some problem with echo if I'm remembering. Dr. Pankaj. Hello. So he is Dr. Vikram Ambalal Sarabhai, the father of Indian space program. He only sheets, or I can say initiated the space activity in India. Right now, what we are seeing is space science and space technology, or advanced space science and technology, right now playing a vital role for the nation development is none other than the initiative by Dr. Vikram Ambalal Sarabhai. We have so many area in which space science and engineering is playing a very vital role. But if you see the remote sensing, teleeducation, telemedicine, search and rescue, disaster monitoring, interplanetary exploration, all these things is done right now through ISRO. But the main thing, the reason and vision behind ISRO is basically Vikram Ambalal Sarabhai is we must be the second to the none in the application problem of man and that is what actually ISRO till now following. And these are in which the foremost is applications belong where satellite communication, launch vehicle, satellite navigation, Earth observation, and exploration. So this is what the last 6 decades ISRO is doing. So Indian space vision is basically shared, nurtured, and enriched over the years. More than a 6 decade old organization. But the main intention is especially people centric and application driven. So each and every sector or each and every segment is having it required actually hours to speak. But since my today's topic for discussion is basically launch vehicles, I will touch upon launch vehicle development and launch vehicle activities. So these are basically what actually I'm going to explain: space infrastructure, space transportation, space application, and capacity building. And space transportation basically belongs to launch vehicle category or launch vehicle area, in which PSLV, GSLV, GSLV Mark III, and a new generation of HRLV, RLV, SSLV is comes to picture. But if you overall see this main vision for this inception of the organization is basically harness the space technology for the national development. And till now, this is the old figure, but still if you see that more than 225 missions are over. Mission mean combination of launch vehicle as well as satellites. Right, out of that 57 to 58 satellite of PSLV till launch vehicle has been flown through PSLV, now GSLV, and then near about 7 satellites of GSLV Mark III missions already over. Till now, near about 200 satellites, indigenous built 200 satellites launched from Indian soil, and right now orbiting in the space. Out of that, around 30%, approximate 30 to 35 satellites right now working uh, to capture the images or to provide the services, space services to the India. Out of that, near about 20 is remote sensing and approximate 15 is the communication satellites, and approximate 435. But this number may be near about now 434 satellites of 34 different countries we have launched, and we got near about $800 million as a FE, foreign exchange, yeah, to provide launch vehicle services or the space-based services or the application-based services. And this is what actually, if you talk about space in general, if space means a simple definition is the portion or where the full of debris, the portion or the space is can be defined as extreme temperature limits, which daytime comes to 150 degrees Celsius and nighttime maybe minus 150 degrees Celsius. Deep vacuum, zero gravity, radiation, and magnetic field. So these are the hazardous, or I can say the extreme environment condition of the space. And this all together means debris, extreme temperature, zero gravity, magnetic field, deep vacuum, radiation, etc., etc., etc. Is because of that this space environment become very you right or you have to which can sustain such kind of environment. So this is actually, I can say, this is actually the area in which people are focusing, or maybe we have to focus, so that this extreme environment condition has to be bear by that particular satellite, whether it is remote sensing or satellite or communication satellite, and he has to fulfill his own requirements so that the functional requirement or the mission requirement or mission goal can be fulfilled. And as I mentioned, it is started way back in early 1963, and Nike Apache, the first satellite, or I can say first launch vehicle or the sounding rocket launched from Indian soil, that is from Tulsa, Thumba Equator Rocket Launch Station. And from there we understand the complex technology of it is called rocket science, or maybe the rocket science and technology. And then indigenously we developed Roni sounding rocket, RS-200, RS-300, RS-300 Mark II, RS-560. This is for understanding of rocket science and technology. These are, you can say, experimental rockets, right, which can give the understanding about rocket science and technology, right? And this is the saga of all launch vehicles till now ISRO has been developed. We started from SLV-3 in early 80s, then mid 80s around ASLV, Now the operational launch vehicle of PSLV Polar Satellite Launch Vehicle, GSLV Geosynchronous Satellite Launch Vehicle Mark II, and the third generation GSLV Mark III. Now we are planning for SSLV, Small Satellite Launch Vehicle, new generation HRLV, the Human Rated Launch Vehicle, and same time the new generation of rocket, which is called NGLV, right, which is having a more capacity as compared to GSLV Mark III. So PSLV, GSLV, and Mark III is basically operational satellite, and they can put the satellites in a LEO, GEO, or MEO orbits. PSLV is suitable for sun synchronous and LEO orbit up to 2 ton, and geosynchronous Mark II is capable of to carrying 2 ton of communication satellite into geostationary orbit. And GSLV Mark III, right now it is called LVM3, is capable to put a 4 ton of satellite in in geostationary orbit. HRLV is basically meant for a Gaganyaan mission, which is having a human rated. SSLV is designed for small satellite launch vehicles, in which up to 1 ton of satellites can be launched within one quarter, within 15 days, and it can be put in a LEO orbit. Right, it is a good replacement of PSLV. And then NGLV is having a capacity to put a 10-ton satellite in a geostationary orbit, which is under development. As I mentioned, we started from SLV3, right? Its first project director and mission director, successful mission director of SLV3 is none other than the People's President, late Dr. APJ Abdul Kalam. Then his photo is also available here. You can see that. And this first successful launch is done upon on 18th July 1980. Then we augmented and we started to increase our payload capability through ASLV, right? But the drastic changes happening through Polar Satellite Launch Vehicle. Its total weight is approximately 295 ton, and its height near about 44.5 meter, and it can carry up to 1750, around 1.7 ton. But with the due strap-on and size reconfiguration of XL, we can go up to 2 ton also. So this is actually one robust and high reliable launch vehicle we have developed. It is called Polar Satellite Launch Vehicle. It's suitable for the remote sensing applications. Right, till now near about more than 60 missions are accomplished by this PSLV, and as I mentioned, more than approximate 434 satellites for 30 different countries we launched through PSLV only, and got about $800 million. And some of the remarkable missions done through PSLV is launching of IRNS, Chandrayaan 1, Mangalyaan, 104 satellite in a single mission, navigation satellites. This everything will be done through PSLV only. Even that Aditya L1 also launched from PSLV. And these are some missions we have done through space capsule recovery experiment through PSLV. As I mentioned, 2nd October 2008, the Chandrayaan 1, which is launched, the first ISRO mission other than it is coming out from the Earth gravity and go to the nearest celestial body, lunar surface, or I can say to lunar. That is Chandrayaan 1. That is happening in 2008. Then 2019 we did 2000 Chandrayaan 2, and 2023 we did Chandrayaan 3. And as everybody mentioned about that, Chandrayaan 3 is one of the most remarkable experiment and successful mission of ISRO, in which the Chandrayaan 3 landed on the south pole of the lunar, successfully sorted. And so many actually scientific experiments we done during the 14 days period. This is the Mars orbital mission. India became the first country in entire globe or world who has successfully inserted in a first or maiden attempt to reach up to 60 crore kilometer in a single shot. And we plan for this Mangalyaan for 1 year, but still more than 8 to 9 years are completed, and still it is orbiting around the Martian surface or Mars, and getting the good photograph and information, especially topology, morphology, and getting the information related to Mars in a scientific manner, in a very good scientific manner. And this is actually why remarkable, because US in 7th attempt, Russia in 12th attempt, China in particular time up to 7th in 5th attempt has not succeeded, and India become the first country in the entire world in the first time, I can say, maiden attempt. We have successfully inserted Mangalyaan or MOM or Mars orbital mission successfully, and it's become actually credit for India, the recognition of the Indian scientists, especially in space scenario. This is one of the most PSLV 37. in which we launched near about 104 satellites. Out of that, 3 satellites from India and balance 104 satellites from the 6 different countries. Out of that, 88 satellites from US. And this is the exploded view of a GSLV Mark III, means one of the one rocket, in which you can see that most of the rocket payload or elements is basically made of propellant only. So almost 90% is a propellant, and the balance, you can say structure and everything, some fraction amount will go to the satellite only. It means the main purpose of satellite, or I can say main purpose of launch vehicle or rocket, is basically put a satellite in a desired and particular orbit. For that, this launch vehicle, or I can say this type of rockets, are required to put a satellite in a desired orbit, so that against the gravity they can go and put a satellite in a desired orbit, so that they can meet the functional requirement or the mission requirements. And this is the C-25, the cryo technology. It will give the highest specific impulse available in any aerospace engines, which is having 454 seconds. Right. So that's why these all the stages, especially GSLV, Mark II, Mark III, or even new generation rockets, always the last stage is a cryo stage, because it is having a highest specific impulse. That's why the thrust ratio or the payload ratio can be enhanced. And last stage, weight to satellite ratio is always 1:1. So that's why we want to maintain, so that we can get the more specific impulse or more efficient stage, so that we can put a satellite in a indented and desired order in a particular manner with the micron accuracy. And this is the demonstration of this cryo stage. And this is the saga how we develop I can say GSLV rockets, and because this cryo technology is basically a strategic technology. Nobody is going to give as a spoon fitting to you. You have to develop your own. So India, ISRO took around near about 20 years, 2 decades to develop this technology, and right now we are a master of this technology. The same we inculcate, or maybe we will draw to the in SLV Mark III, in which 2 S200, 1 L110, and 1 C25 stage was there. Total lift of mass is approximately 640 ton, and it can carry up to 4 ton of satellite in a geo orbit. Its height is near about 43.4 meter, means approximate 10-story building. So if you talk about in the general sense of comparison, so it can carry only 4 ton in a geo orbit, means approximate 4,000 kg. But if you want to take 4,000 kg into space, you have to build a rocket which have having the weight of 6,40,000 kg, and its height is approximate 10-story building. 43.4 means approximate 44 meter. So now you can assume how much gigantic these rockets are there, but they can put up to satellite 4 ton. So that's why we are going to make a new generation launch vehicle. It is called NGLV, which can put up to 10 ton of satellite in a geo orbit. And this is actually one orbit profile of that first LVM3 care mission, in which we recovered care mission, or maybe the, so that in future Gaganyaan planning can be done. And these are the some of the components. Can say, Columbia, the space shuttle program, Atlanta, in which it is reusable in nature. It means that till now, PSLV, GSL in Mark III, what we have seen is basically expandable launch vehicle, means it is not reusable. One time only we can use it. But when you go to RLV type rockets, in which we can go for a use for maximum time, so that the every time launching satellite in a space, its point of view, or maybe the low cost access to space can be done. So RLV is the best solution for that, at least for the Gaganyaan missions, or low Earth orbit or LEO orbit or remote sensing application can be easily done through RLV missions or usable launch missions. We are going to develop a technology like air breathing, scramjet technology, ramjet technology, so that the most of the fuel which is consumed during the crossing the atmosphere, near approximate 60%. So what we are going to do it, we need not to carry oxidizer with propellant, and we are going to use atmospheric oxygen as an oxidizer for burning our fuels, so that the dead weights, or I can say the carrying of oxidizer can be eliminated, and same time the efficient launch vehicle or efficient rockets can be developed. So scramjet and ramjet is a probable solutions, and right now ISRO is working on that. And one technology demonstration already we did, but still it is going to be operationalized. And these are the actually launch vehicle technologies, in which aerodynamics, propulsion, mission, thermal structure, navigation, guidance and control, NGC, avionics, mechanics, materials. So many things will come. Basically, launch vehicle is a multidisciplinary activity in which almost all branch or all segment of engineering will come. And these are the basically in terms of communication, remote sensing, scientific satellite, experimental satellite, navigation. So these are the type of satellites till now India has been developed. Navigation means it is a Indian owned GPS system. It is used to be called IRNSS, Indian Regional Navigation Satellite System. It is called navigation with Indian constellation. Near about 7 satellites we put in a LEO and GEO orbit so that the proper communication or the Indian navigation can be done, and its accuracy in Indian continent up to 1,500 kilometer is better than your GPS system. Scientific mission, we did so many scientific missions like Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, Mangalyaan, now planning for a Mangalyaan 2, Venus, Aditya L1, Astrosat. So as such, so many scientific mission we have done. And in pipeline, I can say Mangalyaan 2 and Venus is under pipeline. Remote sensing, India is having a highest saga of remote sensing satellite, especially optical remote sensing and macro remote sensing. And right now, the maximum number of remote sensing satellite orbiting around is basically from India. And communication, there are so many D2H navigation and communication satellite India has been launched, and approximate right now around 10 to 12 communication satellite right now working in orbit. These are the some of the satellites started 1975 Aryabhatta, and we started from the I can say from 1 kilometer resolution. So right now we are going to the sub-meter, or I can say few centimeter resolution we have reached. So this is actually the till now the I can say resolution point of view. We have come to 1 kilometer to the some few centimeter and few mm. And these are the application of satellites in which agriculture, water resources, environment, soil, land use, ocean application, forest, geoscience, disaster warning, right? So as such, there are so many applications of the satellite technology as available, and ISRO is using these technologies. And same time, the potential fishing zone and navigation services, one of the prime activities of ISRO. Navigation means through Navig we are providing navigation services, but the same time potential PFZ, you have to provide the information to the local fishermen so that the fish catchment can be increased, and same time and the parameter we are sharing with the fishermen so that based on the getting the more number of fish and exchange. This, as I mentioned, inside application is telecommunication means normally any communication satellite having a telecommunication, telebroadcasting, telemedicine, teleeducation, search and rescue, disaster management, meteorological, cyclone warning system, etc., etc., etc. There are so many applications that are available in the inside series of satellites, and so planetary mission. We are doing this especially deep space network, which is available at around 32 meters of parabolic reflector antenna. Will getting all the information from Mars as well as Moon. So for whether it is Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, and antenna only. The scientific we did and these are the actually till now we have done the scientific experiment. And the same thing we did for Chandrayaan 3. Initially, we have planned for a GSLV Mark 2, but after that, Chandrayaan 3, HLV, we have planned HRLV. And after that, we moved to LVM3. And for that, we have launched Chandrayaan 3 on 22nd July 2023 on approximate time of 12 बज के around 13 या 15 मिनट के आसपास, है ना, we have launched it. And after 42 days of the long journey during insertion from Earth to the lunar atmosphere, we 23rd August.
Ravi sir,
Ah,
I think your slides has stopped sharing. Can you share once again?
okay, no problem.
Yeah. So, Ravi sir, in the beginning, there was some issue from this app side from my mobile, so I was unable to unmute actually.
Okay, no problem.
Yeah. So you can just share again.
extra screen. Now it is visible.
I think it will come, so it is on the way.
You can see it.
For me, it is taking time. I don't know. Kamakshi means, are you able to see?
Not visible.
Not
No,
visible.
sir,
till-
not visible.
1 minute, 1 minute. We will try something.
No issue. Again, you can just try by unmute.
Now it is visible.
Still no.
Not yet, sir.
Yeah, I think now it is. Your folder is visible.
अब दिख रही है क्या?
फोल्डर आपका विजिबल
Yes,
था
sir.
और
फोल्डर विजिबल है, स्क्रीन पीपीटी भी विजिबल.
पीपीटी अब विजिबल है. इसको स्लाइड शो मोड में जस्ट मेक इन टू द स्लाइड शो मोड.
Now
No,
क्या हो रहा है?
I think now it is in the slide show
Okay,
mode.
done.
You can go to your slides.
So this is SSLV, small satellite launch vehicle, which is replaced SLV. So up to 500 to 600 kg of satellite. Now you can up 500 km polar sun orbit. We can easily launch through SSLV. So this is the new generation launch vehicle, which is developed 3 to 4 years back only, and it is assembled within the of 1 week only. So this is very fast, easy, and the same time most economical also for especially remote sensing applications. And this is the new kind of propulsion system we are developing, in which in place of going for liquid hydrogen and liquid oxygen, we are going for LOX methane engines, so that it is easily usable and same time the complexity is very less. And we are going to use for this. And as I mentioned, SpaceX recovery, like boosters, they are recovering the same way. We are going to recapture the entire stage. Right, so this is actually in the pipeline, and most probably within 1 and 2 years, you can see that like SpaceX, we are actually recovering entire stage. Same way we can also recover. And this is HRLV, as I mentioned, India is marching to Gaganyaan mission, in which 3 Gaganauts going to send in a space for 3 to 5 days up to 400-kilometer orbit. So, and already everything has been, and people have already identified. So what we are going to make a human rated launch vehicle, in which this crew model will be sit around 2 to 3 people, and they will go to the space for 3 to 5 years and around 400-kilometer orbit, do some experiment and safely return back. Sending human in a space, or maybe anything going to send in a space, is simple, but returning back is one of the more typical and complex. So that is done through this technology demonstration of Gaganyaan missions. And these are some of the actually engines which is we are working in plan, so that S200 semi cryo, so that the enhancement of capacity can be done. So these are the snapshot of some of the engines which is right now under working, and very soon you can see this will be the operationalized. This is, as I mentioned, heavy lift of launch vehicle. It is called HSLV. So our capacity will be increased up to 40 ton in a LEO, and as I mentioned, we can go up to 10 ton in a GEO. And this is what actually the pyramid, or the I can say the base research funnel, in which most of the activity right now ISRO is doing through the academia and the industries. So we requested mostly through our response proposal, response basket, and even there are so many STC cells are there, in which industry basic science engineering, basically your technology. So the combination of science plus engineering is basically a new advanced technology And the most of the actually space activity, which is called the cutting edge technology, we are going to introduce the cutting edge technology through this innovative funnel, and most of the activity done through our NITs and IITs only. So this is what actually I want to share with you. Actually, one small animation I want to share with you. ऐसे करेंगे थोड़ा देखो ना. स्क्रीन शेयर. पंकज ये दिख रहा है स्क्रीन पे कुछ?
Yes, pardon.
Something GSLE marked the virtual word. You can see on your screen.
That is showing in your folder only, like, but it is not. I think it is coming. Yes.
So you can see rocket GSLE marks the virtual void.
Yes, yes, yes.
Okay, done. So this is what actually I am telling. This is the rocket which carries Chandrayaan 3 to the desired space orbit. If you see its internal view and portion where your Chandrayaan 3 is encapsulated. So this is the portion where your Chandrayaan 2, Chandrayaan 3 is seated. So if you see the internal, most of the rocket is actually full of propellant only. If you compare with nozzle area with your human height, so you can compare the total weight of this rocket is approximately 636 ton. It is visible? It is visible?
Yeah, it's visible.
नहीं just अभी power cut down हुआ था पंकज यहाँ पे इसलिए पूछ रहा हूँ.
So there was some second pause actually. So
Now it is okay ना?
Yeah.
Okay. So this is 636 ton means approximate 6,36,000 kg of total weight of this launch vehicle. It can carry only 4 ton in a LEO orbit, low Earth orbit up to 200 kilometers, and its height is approximately 11-story building. So you can see that the fraction means in terms of efficiency or output, 4 ton divided by 636 ton. So it comes around in a fraction. So most of the rocket weight, or I can say most of the propellant which is associated with this rocket is basically to counterbalance your gravitational forces to put a satellite in a desired and intended orbit. Right. So this is what actually this rocket is there. And this rocket basically carries your Chandrayaan 3. So directly I will go to the launch. So you can see normal all rocket will be launched from Sriharikota. Right. Satish Dhawan Space Center is the spaceport of India, where all rocket till now more than 100 rocket we will launch. All rocket will be launched from Satish Dhawan Space Center Sriharikota, which is 110 kilometers away from Chennai. And since I am going to since I am going to push the rocket to NIT Trichy, so I request this time NIT Trichy person people will actually launch this. So are you ready? So we can launch it. So now this launch pad, now you can see that even how actually rocket will be launched. So as the countdown will start, you can see initial first two heads. These are the mission parameters, and these are the launch location as well as orbital specification in which satellite has to go. So step by step, all the things will be I will explain. Okay. So as soon as the launch will got a launch pad and T0 will be there. So T0 rocket will lift out from the launch pad. Initially only S202 will run, and after that only the main booster 1110 will start burning. Now S200 will be separate out after 25 kilometers. L110 will take the rocket to the higher heights, and approximate 65 to 70 kilometers that heat shield will be separated. Now L110 carry with rocket to up to 100 kilometers. And from there L110 will separate. Now the cryo C25, which is liquid hydrogen as a fuel and liquid oxygen as an oxidizer, will put your satellite in an intended orbit up to 220 kilometers, and from there we are raising the satellite orbit and go up to GEO, LEO, whatever orbit is intended or desired for the satellites. So if you take about Chandrayaan 3, It will put a satellite into 210 kilometer orbit, and from there we are raising their orbit. Around 3 iteration we done, 3 insertion we done, and after that approximate 40-day distance, it has reached to the lunar surface and soft landed on 23rd August. Now C-25 will be shut down, and it will be detach the satellite in orbit. So normally, if you see, this is your Earth, approximate 180 kilometers is your perigee, and approximate 36,000 kilometers is your apogee. And when it is going to inject satellite in a desired orbit, it comes near about velocity of 10.2 meter per second, kilometer per second. It means approximate 31,000 kilometer per hour is its speed. And if you see their graph, so vertical height means y direction height may be approximate 220 kilometer, but if you see the x direction means horizontal, it's travel near about 4,000 kilometer in approximate 875.5 seconds. So this is basically a rocket science in which speed, time, weight is there. And as I mentioned, we are planning only for ELV type, but now we are going to marching RLV type also. So this is what actually I want to show with you. And then this 23rd August is basically the day for the we are going to celebrate as a National Space Day है ना, इसको राष्ट्रीय अंतरिक्ष दिवस के रूप में भी सेलिब्रेट किया जा रहा है फ्रॉम लास्ट ईयर ऑनवर्ड्स, because this is commemorate the Chandrayaan 3 soft landing of Chandrayaan 3 on the South Pole, which till now nobody has done. No country has been done, and after that only that China has did. So, and because if you see the lunar colonization or maybe in future the space exploration or the possibility of life, that can be done only on the south pole of the moon. So that's why everyone is actually exploring the south pole of the moon, and we become the first country in the entire world who has did this activity and successfully soft landed Vikram lander on the moon, and we have put our tricolor Tiranga on the moon. And as I'm in general in my lecture also I used to tell more than 200 registered nations are there in United Nations. संयुक्त राष्ट्र में near about more than 200 registered nations are there. Out of that, approximate more than 50 countries having stars and the moon on their national flag. And India become the 4th country after 23rd August 2023 whose national flag on moon. तो चांद पे झंडा होना और झंडे में चांद होना, this shows the technical capability of Indian scientists and ISRO. So this is from all my side, and once again I congratulate to NIT Trichy, National Institute of Technology Trichy faculty and students for National Science Day 20th February 2025. And as an offset, I have to give thanks and credit to all of you. You are celebrating National Science Day, because the main purpose of this National Science Day is basically to inculcate scientific temper of our new generation, new engineers. And I think this platform, you people are actually doing this activity. So thanks for organizer, especially that Pankaj Soilot from Mechanical Department, who is actually doing this activity. And thanks for inviting me to NIT Kurukshetra. And I hope you can understand the launch vehicle technology which we have developed near about 6 decades. It took ISRO for develop around 6 decades. And the question and answer session is open. I request the moderator to kindly, we can take some 3 or 4 questions, and after that we will wind it.
Thank you so much, sir. It was amazing to listen. I now open the ground for our road audience to have the Q&A session.
So participant, you can unmute yourself and you can ask.
Excuse me, sir.
Yes, please ask.
So my question is, how does ISRO's launch vehicle technology compare with other space agencies like NASA and SpaceX?
Please pardon, or maybe I request moderator to kindly, because I could not hear you properly.
Sir, I'm repeating my question. How does ISRO's launch vehicle technology compare with other space agencies like NASA and SpaceX?
पंकज जी
Ravi
इको
sir.
आ रहा है, थोड़ा बताओगे?
So what? Yeah. So what? Can you hear me now?
हाँ, I can hear you.
Yeah. So I think Shruti is asking. So how is the Indian launch vehicle is different from the other launch vehicle like NASA and SpaceX?
Okay. No. like a difference from them. It is based on the capability and capacity, right? If you want to, you have to go by bicycle or by scooter is okay. But if you want to carry more people, you have to go for a car only. Same way, if you want to put a higher capacity of satellite, you have to develop such kind of launch vehicles. But if you talk about technology point of view, so definitely NASA is leading, right? Even SpaceX also, because they have the space capability, SpaceX is full recovery rocket they have developed. So we are struggling, or I can say we are under development. Whatever we decided, whatever we made it, it is as per our requirements. So till now, as such, no drastic change. Better off if you understand the making of car, na, so then making a truck is also very easy. But so it is just a I can say the leapfrog, or maybe the capacity required. Otherwise, everything is same. As such, no difference is there.
Okay, sir. Thank you.
The next,
Sir, I have a question. How does
yeah, please
ISRO
ask.
Sir, how does ISRO optimize the thrust to weight ratio in its launch vehicles?
This is very simple. Normally the aerospace equation means you, right? And in general, if you want to put it is just a fraction on the slide also, because whatever the structures are there, materials, propellant, XYZ, everything. The main purpose is to put a satellite in orbit, not a rocket. So the main purpose of rocket to against the gravity and put a satellite in a desired orbit. So that's why this fraction or efficiency of any rocket is always in a comes on a fraction only. So this is the very minor, a very small calculation. As you mentioned, if you an aeroplane, how many people can be travel one aeroplane is required as per their you to design it. Same way you to design a rocket based on their payload capability.
Okay, sir, thank you.
Any other question?
Sir, I have a
We will take
question.
the last question.
Excuse me, sir.
Abhimanyu, yes, please speak.
Sir, how does staging in a rocket improves its efficiency?
Actually, what happened? You did not carry any over. Such as if you see just now a launch vehicle animation I show you. S200 propellant, two identical S200 are there in LVM3. As soon as they have their function, they have fully exhausted with their propellants. So there is no need to carry. So that's why they will detach from the main rocket. So slowly, what happens once you detach from the first, actually what ratio, if you talk about ratio point of view, pellet to launch vehicle now, first stage is actually 1:10, second stage 1:5, and third stage is 1:1. So always reduce the dead weight so that you can enhance the payload capability. Because as I told, the main purpose is rocket to put the satellite in space, so the payload can be enhanced. And payload is basically the portion or the electronic equipment which is going to the space. So staging is basically required. So as soon as the work or function is over, it has to be detached from the main rocket. So Nina deadweight along with the entire journey of that satellite profile or satellite trajectory. So shall we close, Pankaj?
Yeah, just a minute. Kamakshi, can you just give your remarks and then I'll take.
Sure, sir. So, as we now wrap up, I would first like to thank the audience for their questions and obviously, sir, for resolving them so wonderfully. I now would invite Dr. Pankaj Sehlot, sir, for the vote of thanks.
Okay, thank you, Kamakshi. So, once again, good evening, one and all. So, it is a great honor for me to deliver the vote of thanks on this occasion of National Science Day. And today, expert talk has been truly enlightening, and I'm sure we'll have gained the valuable insight from the Indian launch vehicle technology and from none other than Sri Ravi Kumar Verma, scientist at ISRO Ahmedabad. I personally know him, I have interacted him, and then I have visited the lab also him. I know he's very passionate about the research. On the behalf of NIT Kurukshetra, I extend my heartfelt gratitude to Sri Ravi Kumar Verma for taking the time to share his experience with us. His deep knowledge and engaging talk has inspired us to appreciate the role of space technology and Indians' achievements in the field. I would like to express my sincere thanks to our esteemed director, Professor B.V. Ramanna Reddy, for his continuous guidance and encouragement in promoting scientific learning and research at our institution. A special note of appreciation to our Dean of Research and Consultancy, Professor R.K. Sharma, for his unwavering support in organizing such intellectually enriching sessions. I also extend my gratitude to all our faculty members for their active participation and for motivating students to explore new frontiers in science and technologies. A special thanks to the Aero Modeling Club and especially the Sachin, Sugam and Abhimanyu for their enthusiastic involvement and contribution in making this event successful. Your dedication towards the fostering innovation is truly recommendable. Lastly, my heartfelt thanks to all the student, participant and organizing team who have made this event meaningful with their presence and engagement. Your curiosity and passion for science are what drive your initiative forward. And I think just to inform Raviji, we have the tech Sparda, which is a tech fest going on currently actually. So our most of the students are engaged in the different activities. So it's still that has been on the same day. So overall, once again, thank you all for being a part of this wonderful session. Let us continue to celebrate and unhold the spirit of science and innovation. So I hope this has been very useful session for all of us. And we are thankful to Sri Raviji. Personally, I know him as I mentioned, so we'll be meeting in future also. And I think we are fortunate to have you with us. Thank you. This is from my side. So we can close here. So if any, let's say, remark from the Ravi sir.